Do the alternate definition of derivative, finding f prime of 2. So we want the limit as x approaches a of f of x minus f of a over x minus a. So in this case, we have the limit as x approaches a, f of x would be 1 over x, minus f of a, which in this case would be 1 over 2, over x minus 2, excuse me. So we're finding the derivative at x equals 2. So in this case, your a is 2. So once again, I have a complex fraction. So I'm just going to multiply everything by 2x. So I get the limit as x approaches 2. Let me change that to 2. Of 2 minus x over 2x times x minus 2. So what I notice is I can factor out a negative 1 here and reduce. So I get the limit as x approaches 2 of negative 1 over 2 times x. And so as x approaches 2, 1 over 2 negative 1 over 2 times 2 is negative 1/4. So we get the same thing. So we can compute derivative algebraically using our formal definition of derivative, which is the one on the left. And we can also do it using the alternate definition of derivative, which is the one on the right. So I just have a little more to talk about as far as graphs go and derivatives. So let's say here is my function f. My function f goes through negative 2 and 2, and also goes through 4. And it does something like, we're going to make it have a maximum at 0, and it's going to come down and have a minimum at 3. So this is my function f of x. Okay, so what I notice is that this function is increasing from negative 2 to 0. And if the function is increasing, then I know from experience that the slope is positive. And so in this case, we don't want to talk about slope anymore. We don't want to call it slope. We want to call it derivative. So I also see that f is increasing from 3 to 4. So I see that from negative 2 to 0 and from 3 to 4, the derivative is positive. So I know that when f is increasing, if f is increasing, then f prime will be positive. And I also see that f is decreasing. The function is decreasing from 0 all the way to 3. From 0 all the way to 3, the function is decreasing. So wherever a graph is decreasing, its slope is negative. So I know now that if f is decreasing, then f prime will be negative. So since I know that, I can almost try to draw a graph of my derivative. Very primitive for now, because we don't know a lot yet, but we do know that from negative 2 to 0, the derivative is positive, excuse me. And when we say the derivative is positive, and we're thinking of the graph of the derivative, positive should be above the x-axis. So from negative 2 to 0, my function needs to be above the x-axis. And then I also see from 0 to 3, the function is decreasing. So where the function is decreasing, then the derivative is negative. So when we're looking at the graph of the derivative, negative needs to be below the x-axis. So I know from 0 to 3, the graph needs to be below the x-axis, and then from 3 to 4, it's increasing again. So from 3 to 4, it needs to be above the x-axis. So that's kind of primitive of how we use the graph of f to determine the graph of f prime. But the basic stuff that I need you to understand today is that anywhere where a function is increasing, its derivative will be positive. And anywhere where a function is decreasing, a derivative will be negative.